Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
Hi, everyone. Welcome to a brand new episode of the Clear to Send podcast. I am your co-host, Roel, alongside with Francois. How are you doing, Francois?
Very good. How are you, Roel?
I'm doing great. We're here today to talk about designing Wi-Fi for lecture halls in universities. I had the fortunate experience of having to deal with it recently. Excuse me. And I thought it would be a good time to actually talk about it and give our thoughts on designing for it, and also a look of the scenario that I was presented with a lecture hall. What do you think about lecture halls, Francois?
Yeah, well, they're interesting environments for us because, they're considered high density. So we have to, make sure we take that into account when we design. And then, for us engineers, it's always a nice, a wait, like we have this little wait period to know if our design is going to work properly, whenever the lecture is full. So we always have this little apprehension to see if it's going to work. So it adds a little challenge to our design work, I would say.
Yeah, indeed. Because usually in universities, when you do get to do the installation, there's no students there. So usually that's either during break in the summer, and then you have to wait for students to come in and they do the lecture, and then maybe you'll hear back the next day or maybe next week of how that went.
If you don't hear anything back, it's a good sign. Yeah,
usually it's a good sign. Sometimes I think, because a lot of times those professors and students don't know who to contact when it didn't go very well. But in this case, I did get a ticket, and then I got an email. But before we talk about, maybe we can talk about the scenario I was in. So I'll give a brief scenario, and then we can talk about design. So this is a lecture hall on campus. And it seats the seat capacity, right? The fire code. It's 498 people. But of course, when we design, we're going to talk about, how many devices per person, because not usually we're all carrying 2 devices. Maybe it's around 3. But it's got, it's a good decent sized lecture hall. Professor sits in the front, and then there's 3 different sections, right? I call them pizza slices because it kind of looks like a pizza slice for each section. And then, of course, I got to deal with aesthetics. You have challenges with mounting hardware somewhere, but that kind of paints a picture. So, earlier when we started this episode, you talked about high density. But nowadays, I think it's also high capacity because of the way some of the professors are teaching. So a lot of, I think previously, and if you remember being in lecture halls as a student, you would just sit there and listen, right? You're not really doing anything. Mm-hmm. Maybe you're just surfing the web. I've sat in a lecture class just to see what's happening. I see students that just watch videos, football games, recaps of games, while sitting there browsing social media. And so with social media, I have to consider videos that just automatically play when they're scrolling. And then it's a BYOD environment, right? Like we have no control over those devices. So you have to come up with your best guesstimate of what are the device types that are going to be on this Wi-Fi network. Mm-hmm. And then we got to deal with the aesthetics. Of course, you can't just mount anything anywhere. There's usually somebody that will dictate what you can and cannot do. And then I also have to deal with different ceiling heights. And some of those heights can be rather high. So I'm dealing with 15 feet, sometimes 25 feet in the lecture halls because of the way the seating arrangement is. It's like an auditorium almost. So it's not a flat classroom. It starts on the bottom and it makes its way up. And it almost looks like it can be a second floor or even a third floor. Oh, and then there's the applications that are used as well. Right. So those are the challenges and the considerations we need to take into the design for a lecture hall. Did I miss anything there?
No, I think you're good. I've done a couple of big classrooms like this or auditoriums. And I think that, I think what you said is important. A couple of things I remember is, installation of access points and antennas. That's something that's not always straightforward. You have to think a little bit about them.
Yeah.
Sometimes you have access to like the attic above the ceiling.
Yeah.
Which makes it a little easier to kind of study options.
It could be easier or harder depending on how that ceiling is. And I'll share some photos in the show notes because there is a ceiling where we install the antennas and the APs. So you can't even see the APs, but you do see the antennas. I didn't have to crawl in that ceiling. We had an installer do it. And I remember how challenging it was for him. He said he thought he was going to fall through. And if you're going to fall through that ceiling, you're going to fall about 30 feet.
Yeah, because it's pretty much just drywall, right?
Yeah, it looks like it.
Yeah, you have to be careful. And one challenge I had as well when I did some of these for one of my customer is actually finding the antennas after the installation, because they had like a dark.
Okay.
Yeah, they had a dark ceiling, and then the antenna was also dark. They used like some sort of coating on it.
Yeah.
And so, when I went back to do my validation, none of the lights were on because it was off. And so to find the antenna, I used a flashlight to kind of find the antenna when I was doing my validation.
And hopefully they
specific to that environment.
Hopefully they installed it properly.
Yeah, it was installed properly. It was working pretty good. So everything was fine. Yeah.
Cool. All right. Well, let's talk about then in the design phase, kind of our approach. So you and I probably take different approaches. Like our design, the way we tackle this is not always the same. And although you and I have worked together in designs, we just both approach it differently. So in this one specifically, I always at least come first with, all right, what is my installation possibilities here? Because I don't want to do a design and then have someone tell me, no, you can't do that. And so I'll usually meet with someone on site and I say, all right, what's off limits in this room? What can I not do? And so in this room specifically, they were like, we just put up new walls, which are acoustic walls. They're not your drywall. So, I mean, there's a drywall, but they put like acoustics on top of it. And so they said nothing to penetrate the walls. So really our best option was ceilings, the ceiling. So that's perfect because I prefer to do the ceiling versus a wall, just because I don't like the signal coming from the side, which then just kind of blankets the whole room almost, or it will blanket the whole room, and then you got someone in the middle who has basically the people in the middle will get the worst signal because then you got to account for the bodies as well that are sitting there. And one thing that I do with the building manager, and I've been successful in this, is I always bring two options. So during the walkthrough, I will bring the hardware with me. And in lecture halls, I bring just the antenna that I would use, thinking that I will hide the AP in the ceiling and only have the antenna showing. And then I bring a co-location mount with the AP and the antenna. And if you guys have seen co-location mounts, they're pretty big and they're very visible. And I know that building managers, when I say, which one of these would you prefer me to install? They'll always go for just the antenna. And that's usually what I want to use. So I just kind of trick them into picking. Yeah. So they'll just say, no, I don't want that ugly option. It's going to look bad in my building. Knowing that I'm not going to install that anyways, I just make them agree to the one that I originally want. So that's my tip.
Yeah, antennas, I think nowadays they can be, they're the good option because for the aesthetic aspect of them, they can be nice. And then for the RF aspect, they're also the best choice for this situation here. So
yeah, exactly. So we'll talk about antennas because I prefer to use antennas in this scenario versus using the built-in omnidirectional APs. And I'm sure you're the same way, right, Francois?
Yeah, definitely.
What about doing like a predictive versus AP on a stick? Do you ever do AP on a stick surveys for lecture halls?
So the one I did, I think we did predictive, if I recall. But I did go on site just like you to kind of study everything, study the mounting options, what we could do, what we couldn't do. The one I did, they also have like some sort of stage, so it could like become somewhat of an auditorium as well.
Okay.
So we had to also account for that stage area and how to cover it. So we actually ended up with different options for the antenna mounting, because in the stage we couldn't use the ceilings because you have a whole bunch of backdrop and stuff over there. So we had to use the walls. But yeah, so I think we did a predictive, but I had a very good understanding of what I could do. When you have different levels, I measured every height.
Yeah, that's important.
So I could model that in the predictive, and then in Ekahau I use the like the hole in the floor features, so you can actually model it with different heights, and it worked pretty good.
Okay, cool. Yeah, I don't do AP on a stick in the lecture halls only because
it's not convenient for that.
Yeah, it's not easy to do the tripod and you'll end up being in an area where it's uneven. It's not a fully flat surface, or it doesn't fit the tripod. So it's almost impossible to do that. You may be able to do it like on the bottom where the professor sits, but that's about it, right?
But then in these environments, you're limited by capacity more than RF. So if you if you use the right antenna, you should be fine in terms of RF. It's just a matter of finding, or figuring out how many APs, how many radios we need to make it work with the number of devices that we're going to have.
Yeah, and even then, I still feel that with the APs, I'm still limited with how many APs I can do, because even if they pack that many students into, like this one's 498 seats, that's let's just say everyone brings a second device. We're already at 1,000 devices, and to support 1,000 devices in this specific room, like I think I've already redesigned it to the maximum amount of APs I can put in. And even then I'm still kind of weary on the RF, because I know signal propagation will be pretty wide, even for a single AP, even if I picked a narrower antenna. But I know we can talk about that too. But so speaking to the seat capacity, we got to take capacity into consideration in our design, right? So I always look at the fire code. Like there's usually something in the room that says how many people can be in this room, right? This one said 498 people, and I'm like, wow, that's a lot of people. Times 2 devices, that's 1,000 devices. But then there's something called like a take rate, where not everyone is going to be using both devices at the same time, right? Or not everyone will be on a laptop doing something, right? So there's usually some sort of take rate, whether that's 80% of the people that can fill the room will be on Wi-Fi, for example, or maybe it's 100%. Like you got to talk to the professor, maybe sit in a class for a little bit to see what's going on. And so that's how you kind of get to your device capacity is, all right, I got a seat capacity. There's 500 people in this room, definitely 500 laptops, and I'll consider all their phones as well. So now I'm at 1,000, and that's what you can put into your area in Ekahau. So we'll talk about Ekahau. We use Ekahau for our designs, but it's the same for other applications as well. Is there anything you take into consideration there, Francois, for at least device capacity?
Yeah, and when I have this discussion with my customers, usually you have to kind of set expectations as well, because sometimes the customers, they all come and tell you, you know what, each students will have 3 devices, and they just think that all 3 devices will be connected to the Wi-Fi streaming in Netflix or something like that. So sometimes you kind of have to set the expectation and say, you know what, even if the students have 3 devices, it doesn't mean that, or even if you think that all students will have 3 devices, it doesn't necessarily mean that all of them will have 3 devices. And then out of these 3 devices, will all of them be connected to the Wi-Fi at the same time? And then even if they're connected to the Wi-Fi, will they be actively using the device? Like, it's hard to believe a student will be actively using 3 devices at the same time, right?
Yeah.
So you're gonna have to set expectation as well, and then try to get the real view, or as close to the real usage as possible when you talk to the customer, to try to understand exactly how the place will be used. Because most of the time, what I've seen is they'll tend to overestimate and overestimate. And then in Wi-Fi, if we over design the Wi-Fi network, it's not going to work. So we're going to have to find the right balance to make it work.
There is such a thing as too many access points.
Yeah. I mean, we can over design the wired network, put 40 gig everywhere.
Yeah.
And it's going to work. But in the Wi-Fi world, it doesn't work that way. That's what
exactly.
makes it a little more challenging.
That setting expectations is so big. So I'll tell you what happened here in this scenario. When the professor sent an email out, there was I was trying to analyze his email because I was trying to understand what they do in the class. And because they do a different teaching method where I remember the professor calling it active teaching, where they tell students to do something, right? So this is where I talk about the take rate. Previously, I would think not all students are going to be doing something, but in this case, they want the students to do something, specifically like do something on a website. And so now I have to consider that. So I have to ask, what are they doing? What are the applications they are using? So I can help set some expectations here. And then he told me it's like low bandwidth, but there was one comment in his email where he said he mentioned the word Zoom and then Q&A. I'm like, okay, fine. Q&A is like text, but hey, are they all opening Zoom? And then because, there's some students that are remote. And I'm like, so are they all opening Zoom with video? Because if that's the case, this network's going to crumble with 1,000 students opening Zoom. And he's like, no, they don't use video. And I'm like, okay, good. And so in that case, I was like, well, can you tell your students not to do any video, like anything that's not class related during the, like in the beginning. So that way you can get all non-essential traffic off Wi-Fi. And that way, if you need to have them do your thing for the class, this was a computer science class. So this has something to do with like programming or whatever. They had to pull up a page. That way that application can work. And so like that helps set the expectations, because I had to tell them like Zoom will kill the Wi-Fi network if they're all doing it, or any other video apps, it's going to kill it. And so he did that and it ended up being pretty good. So
you should do a test now and ask him for everyone to use the video and see if the network will hold up.
Yeah, go back to what they were doing, right? Like so I have a before and after, and we can talk about that. But going back to the design, like I did use in Ekahau areas and set the device counts, but then I also had to estimate the application usage as well. So when I do that, I also set some devices that there's going to be students who aren't going to pay attention, right? So I set my best guess on how many devices I think will not be paying attention, but will need a higher amount of bandwidth because maybe they are watching videos. I don't know, streaming something. I've seen somebody stream videos, but they have their headphones on and they're just not paying attention. So I just keep that in mind because we got to be aware of the application usage and the duty cycle for these applications. And in Ekahau, you do put the device count, but I think, and maybe you can correct me if I'm wrong here with Ekahau, but Ekahau thinks that whatever device count you put with the usage, it's going to consider that as like 100% of the time during that, in that area, right?
Yeah. So you have to take into account, out of the connected devices, how many will be active at the same time.
Yeah, exactly. So maybe in your scenario, not all 498 students are doing something. So you could do your take rate, right? You can do 498 times whatever the take rate is, whether that's 50%, 25%, and then that could be your capacity right there, right? Okay.
And you can document that in the notes. So that's usually what I do in the notes. I would say, seat capacity, 492, number of devices expected 1,000, number of devices connected. You can say, I don't know, like 700, and number of active devices, 300 or 400, whatever.
Yeah. There's a lot more to that, right? It's more of like that helps determine your capacity. And when you look at the heat maps, you can tell whether or not you're meeting that capacity. And you can do it the manual way.
There's a good video from Andrew Van Nage.
Yes.
WLPC, like a few years back now. But if you Google capacity, WLPC, Andrew Van Nage, you'll find his presentation. Yeah, he goes through all of this.
Yeah, his stuff was very very useful in my case, because that's when I first did this design, I used his capacity planner. But nowadays I just use the capacity planner that's built into Ekahau. But you can do it manually if you want and do the math. I don't do that anymore because we have the tools to help figure that out. But that's one way to do the capacity.
And if you look at the capacity planning part of it as well, the challenge we're going to have in the future is, it was already pretty guesstimate because you only assume the devices will use the maximum data rate they support.
Yeah.
So from that standpoint, it's already a guesstimate. But then now with the new Wi-Fi, Wi-Fi 6 and OFDM-A and all of these different things that we don't even control, it's going to be even harder to kind of know, how much how the airtime is used. So it's going to be even more of a guesstimate in the future. I guess we're gonna have to trust some of the equipment at one point, or validate after the fact and try to do the best we can, because it's supposed to make it better.
Supposed to, yeah.
Yeah, but it's yet to be proven, right?
Right. Yeah, it's too early. So once we get to that point, I think people will start validating, even though the tools will need to catch up. We'll start validating and we'll find out whether or not it is working the way we thought it would with the future technology. So that's something to consider even for your upgrades currently is, maybe you'll want to upgrade in order to take advantage of that. But without any good data to work off of, you may be the first one to come up with that data.
Yeah. So always try to, I guess, do your best estimation as much as possible, talking to the people. What you did is really good, like sitting at the back and taking a look at what students are doing, how busy the place is and stuff like this. I think it's a good indication of what, how the place is used.
Yeah, it gives you a good idea and you understand, all right, here, this is what the usage will look like, because students are a whole different beast.
Maybe you learned something listening to the teacher as well. You never know.
I wasn't even paying attention to the teacher. I was too busy looking at all my tools. I could have learned something. It's computer science, but whatever.
Int is an integer.
I at least know that. I could have raised my hand, I guess. So the next thing in the design then is basically coming up with your access point and the antennas. So I definitely go directional antennas in this scenario, and you got to choose wisely, right? Your antennas have different beam widths. So that's primarily what I'm looking at is how wide of a beam width do I want? For me, I wanted something pretty narrow, like under 60 degrees. So that way I can shape it to one particular area and try to get those devices on that AP, right? So kind of like a manual way of trying to load balance clients per AP. Like I would place APs and antennas on different sections of where the seating arrangement is.
Yeah, and I think that's a challenge for the RF because even if we use low beam width, low angles, the RF will still go everywhere in the room.
Yes, it doesn't just stop at the beam width.
What? Really? Yeah, so it goes down sometimes drastically, but the RF kind of continues. So sometimes you may have client devices that just enter in the room, connect to the first AP, and stay connected there.
Yeah,
even if the student just go all the way up to the next section.
Yeah, and that's where even transmit power is important too. Like you can only go so low on transmit power.
You can only go so low, and plus usually those antennas they have gains that are above average, I guess. So yeah, that's going to bring that up a little bit as well. So load balancing, like you said, we can use the RF a little bit with the directional antenna, but sometimes it's not enough. And we need to use other mechanism to make sure that, not everyone just connects to the first AP that's in the room as they just come in and roam to that AP.
Yeah. And speaking of that sticky client issue, like understanding where students come in to the room is important because if you do place an AP and antenna there, highly likely they'll stick to that AP, right? Because they come in, their device connects. You may think, okay, their devices will be turned off or closed at that point. I'm like, nope. I see a lot of students who just walk in with their laptops open. They're like walking and working at the same time, or walking and watching a video.
They didn't finish their homework before class. What?
Yeah, they so
that never happens, right?
I know, it's like all the things that I thought and had assumptions for, they're wrong. Like, but yeah, if you place an AP right at the entrance, just be careful that they may just stick to that AP. So you may want to maybe you're trying to support roaming. So maybe put it outside of the lecture room or auditorium and maybe keep that at a lower power. So when they walk in, then hopefully their device will see the other AP at a better transmit power and decide to roam. So in my case, I have things that are APs at around 14 dBm because we've got a high ceiling. So I can't really go too low. Otherwise, I now start creating some coverage gaps where people are getting signal of around negative 65-ish when I was taking a look at some of them.
Low SNR, yeah. Yeah,
they'll have low SNR. Some of those people at the in between antennas will start slowing down other people because they've got lower signal. So when we did a validation survey, one AP on one side of the room, the signal does go all the way to the other side of the classroom. It's not the strongest signal. I mean, it's like at the edge of that beam width. But I mean, if you were a laptop, you would probably stick to it at negative 65, right? So we were trying to pick the ideal transmit power, and in our new design, we picked a different antenna that's a little bit more narrower. So hopefully that works, and we'll cut that off a little bit more to maybe negative 70.
So I think we have some tools inside the controllers that help us to do some of that load balancing. You do have Cisco, right? Yeah,
we don't use any of the load balancing features.
Maybe you can use some of the RXOP stuff.
Yeah, because you can set that to an RF profile, but I don't remember off the top of my head if you can do load balancing per AP group, which I don't think you can.
The load balancing stuff, I don't like to use them because sometimes it goes against what the clients wants, and then the clients end up not liking the AP, and that can create issues. But one thing you could do is, and I think I learned that from Peter McKenzie, is you can limit the number of association per AP.
Yeah.
So, the first AP you have in your auditorium, you can just limit to 50. And then the 51st client that comes in and wants to connect to that AP will be denied. So it will just connect to another AP.
Yeah, I think I'll want to. Yeah, that's a good idea. I'll try to test that because what I don't want, because I've seen that with like Meraki and it didn't look pretty, where the client just kept trying to connect and then the AP is like, no, don't connect to me. But he's like, no, I want to connect. And then and then with Apple, right? Apple will like blacklist that SSID. So I don't want that happening. So there's like so much we have to consider in these designs, but I do like that at least maybe cutting off the association. But if we're using antennas, that may be useful in our scenario, because then at least there should be another, if it's still trying to find an AP to associate to, maybe that AP it'll join to. So we'll try that, but definitely we don't use load balancing, because I'm in agreement with you. I don't like the way the devices have no idea that they're being load balanced, basically.
Unless you can use 11 V and key, maybe, but like you said, you're in a BYOD environment. So.
Yeah, we don't know who doesn't support it, so we just don't turn those on. So that's the other. So that's why I never mentioned any of those, because we don't use them. We don't use 802.11 K, V, and R in this lecture hall type of environment. So from there, then once you have your design, you're obviously looking at heat maps. So the ones that I pay attention to are like signal strength, secondary signal strength, airtime utilization, capacity, and I put everything in super accuracy with a detailed view. How about you?
Enough APs for that, right? Yeah. And the co-channel, have you ever tried, I don't know, it's a question like this, but have you ever tried to go 40 megahertz wide channels?
No, I don't do. There's another lecture room next door.
Yeah, that's usually the issue. It's like in the center of the building, right?
Yeah, and so we've tested signal propagation to other rooms, and with using directional antennas, the signal pretty much drops off once you leave the room. But there is another lecture hall right next door, which is why we don't use 40 megahertz. So I think there's like 3 lecture rooms there, and then also counting the APs that are right outside of the lecture hall. So we don't do 40 megahertz there. We may do it in like a small office, but usually there's there's other APs around, right?
Because if you think about just clearly, capacity alone and airtime utilization, if you use a 40 megahertz wide channel, you should allow your clients to speak faster. And in theory, they should be on and off the channel faster. But like you say, it's given the premise that it's you don't have a lot of other APs around the room.
Yeah. Now, if the other classes weren't doing simultaneous classes next, like one room and the other room, then maybe we could consider that. But I've looked at their calendar and they do have like the same class in the other room. So it gets crazy. And so in this case, we when I tested it, when I looked at it, when the professor said it was an issue, I saw over 1,000 devices connected. Each AP had a channel utilization of at least 70 to 80%. And in this room, we have 4 APs. We're using 8 channels. So two of the APs are dual 5, but they're using a Dart connector. So they're dual 5. And then 2 of the other APs, they're using a dual band antenna. So we have 2 2.4 gigahertz channels and 6 5 gigahertz channels. And so after speaking to that professor and giving him some expectations, I also looked at the channels and found that there was one channel that was overlapping with another. So because when I was looking at the utilization, I saw it looked the same on another AP, and they just happened to be on the same channel for whatever reason. And so I changed that channel. I also saw that there was a rogue AP that was 80 megahertz channel, which was being used in the classroom. No one knows what it's for. And so I kind of avoided that channel as well. And on the next class, which was 2 days after, same amount of students. They actually overfilled this class, right? So I was like, "You guys don't do that. I'll call the fire marshal on you." But they overfilled the class, so there were people sitting like in the where the stairs are in the hallway. So it was over 500 people. But on the next class, same capacity, but I got the utilization down to about 60% for pretty much all the APs. And on one AP, there was 344 clients connected.
Wow. That's quite a bit.
Yeah. And so with that, the professor said things were way better. Like he told them, don't play anything unnecessary, like the videos and whatnot. And he said everything worked just fine. And so now I'm like, do I need to redesign? One of the key stuff I guess I took away from what you just said is the channel planning. Yep.
And I've seen this firsthand as well in some of the event Wi-Fi I've done. If you overlap some channels, if multiple APs are using the same channel and they can see each other, then you're gonna have, your channel utilization go all the way up to, like I said, 80%. And when it goes up that way, it's going to be slow for the users.
Yep.
But if you take the time to kind of make sure all of your channels are assigned properly, you're putting all the chance on your side.
Yeah, I made very small adjustments, right? So I did channel changes. There was an AP that was capable of doing dual 5 because we had a dart connector, but it was operating on 2.4 and the other antenna on 5 gigahertz. So I made that one a dual 5 instead of 2.4. And then I changed transmit power for 2 of the APs. One of them was too low of a signal strength. I think it was power level 6. So I just increased it 3 dB to 5. And then one of them was too strong. So I brought that down to about 14 dBm. So that way because that signal propagated like way too far. And so I was seeing like too many clients on one AP when one of the other APs had way less clients. I think I can't remember. It was like every AP was over 100 clients and one had like 21 clients. So I had to change the transmit power. So after that, like the classes seemed to work fine, even with a full classroom, all 498 seats taken.
Yeah. Which is very nice. It's nice to see the before and after, after your changes. It's nice to see that, you made it better. Yeah, it's great. It's great to see that.
It's just kind of hard to tell, right? I was doing everything remotely. I wasn't there in the class, so I have to rely on the professor. So I would send him an email saying, "Hey, how did your class go?" And he was like, "Yeah, it actually worked way better this time. Like everyone was able to do what I wanted them to do." And I was like, "That's perfect." Because if I'm going to order new equipment, you won't see it for 5 to 6 months because of the shortage. So I set that expectation. It's like, okay. And then of course, after that, once a professor talks, like other professors start talking. So in the course of 2 days, I had to design 2 more lecture rooms because other professors chimed in and were like, yeah, we also can't do this in this room. And I'm like, oh man, okay. Like, I got to redesign them anyways because it's time to upgrade those APs. But, when professors talk and once word gets around, you fix something, like other professors start chiming in.
Yeah.
So that was...
And sometimes, I was going to say, depending on the size of the room as well, if you're doing like bigger rooms, like auditorium and stuff, sometimes you're going to be limited by just the RF alone.
Yeah.
Because even if you use like very, very narrow antennas, you only have so many channels we can use on 5 gigahertz before having to reuse them and having some channel capacity issues. and hopefully that's where 6 gigahertz can help us a little bit.
Yeah.
In the future, by having more channels, hopefully we can also support higher densities in these type of environments.
I just think though in lecture hall, like in universities, we probably won't see 6 gigahertz really for a long time because these students don't upgrade their laptops that often.
Yeah, it's going to take a while since it's a hardware shift, right?
Yeah.
Because it's hard to get hardware right now, right?
Yeah, it's difficult. So you're going to have those APs that support 2.4, 5, and 6 gigahertz.
plus the client devices, right?
Yeah, you need those clients. But at least maybe you can transition to it, right? You can start broadcasting on 6 gigahertz and see how many start picking that up. And then you can start planning the actual migration, maybe phase out 2.4 in those rooms and only do 5 and 6. And eventually you'll just get to 6 gigahertz only, maybe in 15 years.
Yeah, we'll see about that. I'm not sure.
Yeah, so
we're still working with 2.4 for a while.
Hey, I can tell you guys, I did have 2.4 gigahertz enabled, and there were clients on 2.4. It wasn't a lot, but they were using it, and channel utilization was kind of high for some of those APs. But again, that's why we try to get people on 5 gigahertz, because on the 2.4, I think channel utilization I see going up to 40. But at least, if that 40% was on that 5 gigahertz channel, I think that would have actually brought the 5 gigahertz channel utilization to about 100%.
What about the? Did you check the wired usage? How much you were using on the wired side?
It wasn't that much because at this much traffic, well, during the time that it was failing, it was enough because there wasn't actually that much traffic being pushed through. But we have switches with 10 gig uplinks, so I think that's important to consider. Is if you do your capacity planning and you see, and I don't know how many APs you have, but you might want to see the aggregate throughput that you need, the bandwidth, and make sure your uplink can support that, right? So if you've got each AP doing 200 megabits per second, I don't know how many APs you'll have. Like once you have 5, you're going to saturate like a gig uplink interface. So you might want to keep your eye on that.
Yeah. Are you saying we don't need multi-gig?
No, we don't have no multi-gig on campus at all. We don't use it.
Yeah. Okay. Let's not talk about that. No, but I agree with you. The switch is important. Yeah, because you're going to have a lot of APs connected and the PoE as well.
Yeah. I've gone through enough scenarios where we were using 8-port switches, but once we started adding more APs, well, obviously the port count doesn't fit. But then even when we added new APs and it would still fit on the 8-port, for the 8 ports, we would run out of PoE. So we would have to upgrade those switches as well.
Awesome.
All right. That's all it was just my experience last week dealing with lecture halls.
No, it was good. Thank you for your input. I think it's great that you can actually do some, changes, testing, and see how it improves the network. Sometimes that's a piece that I don't do, and because usually I just come, design, validate, and leave, and I don't get to play with the infrastructure after the fact. So the fact that you can do some of this stuff, test different scenarios, I think it's great that you're able to share that with everyone, because you'll have people in my situation as well that we don't get much visibility after the fact when the network is in use, and sometimes we kind of miss it a little bit. You want to know how you're doing.
Yeah.
So we just rely on what the customer is telling us. It works well, or sometimes we don't have news, and no news, good news, I guess, in those times. But to be able to have graphs and prove it's nice.
Cool.
Nice.
Well, that's all we have for this episode. We'd be interested in hearing what your experience is and what other tips you might have for the lecture halls you've been doing. So if you head over to cleartosend.net/274, we'll include some images there and some other resources that are useful for planning and designing lecture halls, high density and high capacity. And you can leave your comments there. But we want to thank you guys for listening. Bye, guys.
Thank you. Bye-bye.